2, 1. Welcome to the Bytes of Intelligence Podcast. Today I have the pleasure of speaking with Dr. Tom Crawford, better known as Tom Rocks Maths. Dr. Crawford is a mathematician at the University of Oxford and Cambridge, where he teaches maths and researches fluid dynamics. But he's also a viral educator and a passionate science communicator on a mission to make maths not just accessible, but also exciting. Whether it's through his YouTube videos, BBC appearances, or his unique naked mathematician approach, Dr. Crawford has broken the boring maths stereotype, and he's inspired countless students, myself included, to see the beauty and creativity in maths. At Imperial, as we've just seen outside, so many students have been influenced by your videos and chosen to study their STEM subject due to your passion. So I can't wait to dive into this journey, your passion for teaching, and of course the way that mathematics truly rocks. Dr. Crawford, thank you so much for your time.
My pleasure.
Okay, perfect. So I thought the best way to start the podcast normally is just to go briefly into your childhood. So please could you talk me through your childhood? What were you like as a kid? Was maths always an interest? Was it like an early passion for you?
Oh God. My main passion as a kid was playing football.
Okay.
Right? So I was like huge nerd, without a doubt, but also like happened to be really good at football.
Uh-huh.
So I actually had trials when I was like 10 or 11 for like a few, local teams and stuff. Didn't make the grade, but like, I would play for the school team, play for my local team, county, etc. And so I was like, I think if you ask me, anywhere from the age of 7 or 8 through to like 15, what was I going to be when I grew up? It was like, I'm going to be a professional football player.
Really? Wow. Okay.
But then obviously it didn't work out. I wasn't quite of the grade required. But also I think as well as really enjoying football and playing a lot of football, I just love learning. Like it's true now, and I think even more true when I was a kid. Like I enjoyed school. Like, I used to look forward to going to school. I used to like the fact that I'd be doing something new in whatever subject it was. Like I looked forward to the fact that I'd be learning something new.
And whether that's maths, English, science.
Yeah. So I definitely had favourites, right?
Okay.
Obviously maths was my favourite subject, probably followed by like science. I enjoyed geography, history. I didn't really like English.
Okay.
Being completely honest. But
Same
I kind
here.
of, yeah, it's not that I have anything against, English language, English literature, but if I was to think back now, I think I was drawn to maths for two main reasons. So I think because my brain tends to, and I notice this more and more, obviously now I guess I'm aware of it, but my brain tends to think in patterns.
Mm-hmm.
And like, so when I'm like observing a situation or looking around me in the world, like absolutely I see the beauty of being on the top of a mountain and, the views are incredible. But also my brain just can't help but be like, well, there's also another mountain in that distance. And then what's this, estimate this angle, and like sort of, I'm not doing trigonometry in my head, but my brain is just automatically interested in that question.
I get it, yeah. As
As well as seeing the beauty.
right.
Or maybe I'm looking at some trees and like my brain's like, oh, but why does the light come through these certain gaps? Why does that pattern occur? Like I'm interested in like the density of the leaves blocking the sunlight. Like that's just where it goes.
Right.
I just can't help it. That's what my brain does. And I think that has sort of always been there. Mm-hmm. And so I think, science generally, but also like maths in particular is like this search for patterns. And so I think that's why I was drawn to it. And then to come back to the thing about English, I think the fact that in maths there is one answer. Mm-hmm. So there's like 1,000 different ways to get there. And I now, only once I got to university did I appreciate the creativity in finding those different paths. But there is one solution.
Okay.
And I think I enjoyed that as a student. And I think that's why a subject like English, whilst I could do it, I don't think I enjoyed it as much because there were several different answers.
Right.
And so I didn't, I just don't think that kind of like gelled as much with my enjoyment of maths and the fact that there was just that one answer.
I get that a lot. I think I can resonate with the fact that for me, creative writing, I found incredibly tough. It wasn't purely because I think I am creative. I have aspects of creativity. I think maths has quite a lot of creativity within it. But I think, like you said, that subjectivity and not knowing the formula to get to the final answer, that kind of made me a little bit agitated when it came to GCSEs, and that's why I didn't choose it for A-level. But on the other hand, maths, physics, computer science, all of those subjects kind of have a set pattern that you can follow, and I enjoyed getting to that right answer. So I wanted to ask, is there a correlation between people finding maths easy and enjoying it? And is it because it's harder to find English easy because it's harder to find the right answer? I'm not sure if that's phrased okay, but
I don't think it's anything necessarily to do with difficulty.
Okay.
I mean, maybe just speaking from personal experience, but I think it's going to depend a lot on your personality and what you're looking to get out of a situation. So if, I definitely know people that will purposefully pick the most ridiculous, difficult hobby ever because they love the challenge of being like, can I master this thing that's really hard? Mm-hmm. Right. And they want it to be a struggle. And then, I also know people as well, obviously people exist around the world who also are like, well, I'll just pick the nice easy thing that's very similar to what I already can do.
Right.
So I think it's, in that sense, I don't think it's necessarily that people find things easier or harder. I think it's more
personality.
Yeah, and I think rather than... So yeah, I think there's a personality element, but I'd almost say it's more like, how is your brain programmed?
Okay.
So I often talk to people about, when people say to me, how do I become better at maths? How do I, is there a shortcut? And I'm like, well, there isn't a shortcut. Like, it's the same as anything else. It's like, if you want to be a world-famous guitarist touring the world, playing in bands, right? You just have to play the guitar for like 5 hours a day, every day, forever. Mm-hmm. And obviously have some luck. Right. But you have to put in the hours. You're not going to get to that stage without putting in the hours. You have to practice it. It's a skill. Mm-hmm. Like learning a musical instrument is a skill. To me, learning maths, being able to, whether it's manipulate numbers, understand equations, work visually with 8-dimensional spaces, whatever it is you're doing, it's a skill that you can develop and you can practice. So I think just in the sense that you have certain people who end up becoming those world famous musicians, mm-hmm. like they've always put the hours in, but also it's often appears to come a bit easier to them.
Right.
And it's not necessarily that it's easier. I think that's how their brain works.
Okay.
And I think it's the same with maths. So I think with anything, to reach that absolute pinnacle, mm-hmm. I think it's going to be to do with how you perceive the world, how your brain is programmed, which is going to do a lot with, obviously how you've grown up, your genes. There's going to be all kinds of things go into that mix.
Yeah.
But I think that ultimately is going to determine like what you can reach the pinnacle of. But in terms of getting to 8 out of 10, you've just got to practice, mm-hmm. right? Like, I'm terrible at music, but if I just did 4 hours of guitar a day for the next 2 years, I'd be an 8 out of 10 guitarist.
Okay. But is that the same with English, do you think? If you wrote poetry 4 hours every day, would you?
I think so.
Okay.
I think you could reach, I'm not going to win any awards.
Right.
I'm not going to be like a Nobel Prize winning poet, but I think I could.
Okay.
I do truly believe if I put the hours in the work and absorbed other poetry and learned from people, mm-hmm. I think I could become an 8 out of 10 poet. Yeah. Okay. I think
and
that's
that final 2 out of 10 relies on other factors that might be your childhood or your actual personality that you can't.
I think so.
Okay.
I think so. It's sort of, I think anyone with the commitment, the dedication, the willpower, the hours, putting in the hard hours, the hard yards, can reach a level. Mm-hmm. There is a ceiling to it.
Yeah.
But I think anybody can get to, I'm calling it 8 out of 10, but it just felt like a nice number.
I get what you mean. I think I had that similar realization that when I was hitting step to get into Imperial, there were some students at school who, it felt as though they didn't need to put in the number of hours that I was needing to, and they just got the concepts really easily. And I used to speak to them, say, how are you doing this? How does it come to you? And I think many times they just said it just comes to them. So I think that must have been because the number of hours we were putting in that last area was similar, but I think the outcome was slightly different. So would you credit that to maybe their childhood, or because I remember one of my friends who ended up being the captain of the UK programming team, he used to get these things so easily and just didn't need to put in as many hours. But I think it's because when he was younger, there were videos of him proving 0 factorials equals whatever when he was really young. So I think that might have translated into his later part of his life.
And he's probably put those hours in much earlier, right?
Exactly.
And I won't pretend in any way to be an expert on this, but I do believe that when you're learning things at a younger age, it's almost like more valuable, right?
Yeah.
Like, it's like easier to learn an instrument or a language when you're very young compared to when you're an adult.
Right.
Right. So I think there is something in that. So absolutely. If you've been brought up in that environment, I think it's going to pay off later on.
Okay.
Perhaps without you realizing.
Just talking about the brain, there's this idea which I remember coming across, that there's the left side of the brain and the right side, where the left, I think it's the logical, analytical brain, and the right is more creative and intuitive. When I watch your videos, I feel like you've been able to combine both of those brains, both of the sides of those brains, because you obviously have the analytical and the strong mathematical skills, but the way you present it and just your t-shirt, for example, is very creative, and you can present it in a way that's accessible to everyone. Was there something you did to kind of train that, or was it more just your personality again?
That's a good question. I think it's something you can learn, practice, and improve on. Absolutely. Like the very first YouTube video I ever made, I physically cannot watch it because I cringe so much that like it's like painful because it's that bad. Like, so, I leave it up there and I do mention it to people because I think it's an important lesson.
Okay.
Right? To see that I have practiced and put the hours in, learned how to do this, learned how to be on camera, learned how to present. But I would say the way I went about it is actually quite mathematical and quite logical and systematic, because when I first decided, I want to help spread my enjoyment of maths. It was actually my students. So when I was a graduate student in Cambridge, my students used to say that I got so excited talking about whatever maths problem we were trying to figure out in the supervision. I got so excited that they left being like really excited and they didn't know why. And it was just because I was excited.
Infectious.
Yeah. And so they were like, you need to like bottle this and share it with the world. So they kind of encouraged me and put this idea in my head. So then, fast forward a few years and I thought, right, let's try it. But again, I didn't know what I was doing. I'd never been on camera. And that's why my first video was terrible. But I think I sort of did it and learned as I was doing, which is really important, right?
Okay.
It's
you have
very
to start
easy.
somewhere.
It's so easy to be like, I'm going to wait till I'm a bit better,
right?
And you have to start somewhere. And it is going to be terrible at first, but it's part of the fun looking back and seeing how much you've grown. But I think what I did, I'd sort of decided, right, this is my goal. I want to become good at presenting on camera. So I looked at people that I thought were good, right? So that's not saying you should copy them, because if I was trying to copy what's popular, well, okay, it's a different thing, what's good versus what's popular. If I'm trying to copy what's popular, I would just be like a Mr. Beast does maths, which would be terrible. But there are things you can learn from popular. But anyway, it was like, which YouTubers do I think do it really well, right? So basically it's like watch Numberphile, right? And then Matt Parker in particular was a big influence, stand-up maths. And then I was like, right, why do I think this is good? And then, for someone with like Matt Parker, it was like, oh, it's because he's using comedy. It's because of these other elements that bring it to that. And then for Numberphile, it was like, it's because you're taking what feels like a very difficult abstract concept, but you're distilling it down and you're communicating it through nice analogies, through metaphors. You're breaking it up into smaller steps. And so I kind of like, I didn't go as far as like writing down these notes, but I was definitely like mentally studying people that I felt were doing a good job of maths on YouTube, and then trying to copy that or use that to develop my own skills. Exactly. So I think I get where you're coming from in saying it can feel quite creative, but I feel like my approach to it was quite scientific.
Right. That's really interesting. I had a quick question that you mentioned some skills can be learnt a bit easier when you're younger. So I've been tutoring for the past few years about different topics, so A-level computer science, and I've started university entrance, so interview prep. But recently, I've started tutoring a 4-year-old how to multiply. And I wanted to ask, so obviously you lecture at Oxford and Cambridge, so you're obviously teaching these incredibly tough fields. But if you had to teach a 4-year-old or a 5-year-old the 3 times table, for example, how do you go about that? Because it's quite obviously the student you're teaching, or the child you're teaching, is so creative, like they're jumping around and they can't concentrate. So you have to use blocks and different things to teach them. But how would you go about doing that? I'm just quite curious.
Okay, it's a challenge I've never had to do, but my first thoughts would be what I do with any talk, anytime I'm interacting with an audience, is how do I bring maths to them? Okay. How do I bring it to their world? So like what you said, right? Start talking about multiplying numbers. Like a 4-year-old, whatever, doesn't care, right? It's do blocks, right? Have sweets, have whatever, right? So that's 100% is the starting point, is like bring the teaching, the maths.
Bring it to them.
Bring it to their world.
Do you still apply that when you're teaching at the high level? Like because obviously, or at the high level, is there a slightly different approach? Do you bring them to you?
So if I'm going to talk to a school audience or at an event, then I'm definitely trying to bring it to the audience.
Okay.
But with my undergrads, I think it's a bit different.
Okay.
Because at this point, they are already like, their world is already maths.
Yeah.
But in a way, I am trying to bring it so that, you know, I can, if I'm teaching, let's say my second years, and we're doing, so I was recently teaching my second years, and we were doing some fluid mechanics stuff, and we were doing conformal mapping. And then we were doing this like cool problem about the flow around the edge of a teapot. And then I was like, right, so we're going to change this to a simpler domain, blah, blah, blah. How do we do that? And then they were like struggling. And I was like, we did this last term. Okay. And then I just like reframed the problem in the context of the complex analysis we'd done the term before.
Right, okay.
And then they were like, oh yeah, obviously it's that.
Uh-huh.
So I'm not like bringing it into their world of like, let's talk about it in the context of
social
your hobbies
media
or social, yeah. Because I think, you know, they're already in a maths world.
I got it, yeah.
But it's like, it's taking the new thing and relating it to something that they know well.
Mm-hmm. And you love seeing that aha moment of, oh, right, I get that.
Every teacher does, right? That's the, no, you never get old, never get tired seeing that moment, yeah.
Okay, brilliant, perfect. So I just want to quickly now fast forward to your undergrad and your PhD time of your life. So obviously you've done a few years of mathematics and you're enjoying it because you've seen the patterns. But at any point, did you start to doubt why you studied mathematics, or sometimes lose interest in it? Or was there always kind of, what was the goal in your mind?
That's a good question. I think once I got to university, I didn't know what I was going to do. Mm-hmm. Right? I think when I arrived, it's quite fun looking back, because I remember going to an open day, actually in Oxford, and we had 2 talks. And one of them was like to do with prime numbers and number theory. And then my parents were with me, and there was another one to do with rockets, aerodynamics of rockets. And afterwards, my dad was like, "Oh, I enjoyed that rocket one. That's the kind of stuff you're going to be doing." I was like, "Nah, I didn't like that. Prime numbers." I was like, "Number theory, that was cool."
Wow. Okay.
And then when I actually arrived at the university and started studying these courses, like I just went super applied really quickly, because I didn't actually know what the subjects were as an A-level student. And I say this a lot to students. You don't know what pure maths is yet until you get to university.
Exactly.
And then because you just don't really do pure math. Everything you do at school is applied math. Mm-hmm. You might not feel like it, but it's basically
further mathematics. And so even within further mathematics, obviously there's pure stats, mechanics. The pure part for me, I enjoyed it because
it's like calculus. It's differential equations. That's applied.
Is it? That's applied? Okay. Compared to number theory and
pure maths is like proving the square root of 2 exists.
Okay.
That's like a first year analysis lecture. Yeah. It takes a whole hour to come up with this proof, right? Defining it as the ceiling of a set and various.
I remember this. Yeah,
right? That's pure maths.
Okay.
That's pure maths.
That's kind of why my brother and sister are both older than me, and I used to speak to their friends about whether I should do mathematics, computer science, medicine, or I was trying to explore. And when they started telling me about these pure maths proofs, my brain just switched off, and I got kind of scared of mathematics as that abstract idea of proving these random proofs that don't mean anything to me. So even as a Oxford mathematician and who lectures, does that also do you find some parts less interesting than others?
Oh, definitely. Yeah, I've got favourite courses to teach, without a doubt.
Like, but you don't mind doing those proofs, I guess, because you know why they're useful?
I think I've now learnt to appreciate them as proofs, right? So, like, to me, it's not necessarily the result of the proof. It's not the thing that I'm trying to show is true. Okay. It's the process, the logical process that you go through.
Okay.
That I think is really enlightening, right? And that's kind of what you're learning through a maths degree. Unless you're going to go on and do a PhD, you're not going to learn anything helpful by studying topology, right? But you're going to learn how to problem solve. You're going to learn how to start from a series of statements which are true and arrive at the logical conclusion.
Okay.
And I would argue any job in the world is you start from a series of restrictions and you have to figure out the optimal solution.
Okay.
Like any job, that's kind of what you can reduce it down to that.
It's true, yeah.
You have a series of, restrictions, whether it's a budget, whether it's the amount of time you have.
Some parameters, whatever it might be.
You have parameters, exactly. And your job is to find the optimal solution in whatever situation you might be.
Could you give me an example of that? So like any career, could you kind of go through that?
I mean, okay, right now, for example, right? And I often give this example when I'm doing radio interviews, and the presenter will often do the classic, like, oh, I never liked maths, I can't do maths. And then I'm like, right, okay, we're recording this podcast, or we're doing this radio show. In your head, you're figuring out how long we've been going, how long's left. You're thinking about how many other questions you've got to ask. You are literally doing mental arithmetic right now in your head. And they are your parameters, and you're figuring that out. Like, so you can reduce this, what feels like a very creative conversation situation. You can reduce it down to, I have this many questions, I have this amount of time left, and figure out the optimal solution of
it's true.
Which questions, you're assigning a value to each question. Which ones can I squeeze in the remaining time? How long do I have per question? You're not necessarily thinking about it yourself in that way, but you can reduce it to a maths problem.
I see.
And so I think doing math, I'm not saying you have to, take your daily task and reduce it to equations.
But you can.
Well, I think it's more that by studying maths, you learn how to problem solve and process things like that. And then you become better at doing that in a more abstract setting where you're not writing down the equations, but your brain is just more used to thinking logically and processing.
That's really, really interesting. I like that. I remember I was speaking to someone who said that this is quite extreme, but they said they take the calendar at the end of every month and they categorize each of the activities in the calendar by a certain, category. So whether it was social or academic, and then they start applying weights and optimize it, saying that, what do I want to get out? What's the outcome of my year going to be? And what can I do to change it? So I just found that quite interesting that you can actually apply, I mean, that's quite extreme, but you could apply mathematics and, these principles to your daily life.
It's a very, I see it all the time, like productivity stuff based around this. I've never gone that far myself, but I think if you're struggling, I think there is a lot of value in doing that and figuring out like, what actually do I want to do versus what am I doing right now? So you can just make it mathematical, absolutely.
Okay, so the next question I had was kind of to do with this pure maths concept. So throughout history, I feel as though many areas of mathematics are studied purely out of curiosity. I might be wrong, but for example, watching Numberphile videos on, the largest prime number to be discovered, or, all these number theory topics, I enjoy the video, I kind of see it, but I can't really get myself to understand why this is important. And then later ends up being that, wow, this was something which is really useful in society, for example, prime numbers and cryptography, for example. So is there an area of mathematics today that maybe might seem useless and you might be looking, or I might be looking around saying, why are they studying that you think could be useful in the future?
I mean, I'm a firm believer in like satisfying curiosity for the sake of satisfying curiosity. Like, as in knowledge for knowledge's sake.
Right.
Like the way that these things happen is you just discover things. You ask an interesting question, you try and answer it, and you learn about the world. Okay. And to me, that is what it means to be an academic. That's what it means to be human, even, is to have this pursuit of knowledge. But
how do you get that final part, the link to the world? Because sometimes, I mean, I'm picking this prime number example, I don't know why, but you can satisfy your knowledge, which is really incredible and it's really interesting. But sometimes that last part of not finding a link to the world is kind of what tunes me off, in the sense.
But you won't know what that link could be until you've studied the problem.
Okay, I see. Right?
It's like which came first, chicken or the egg type thing, isn't it? It's because, I can give you a couple of examples. So one from my own work. So my PhD. So I now talk about it a lot, and it's related to the spread of pollution in the ocean. It's a mathematical model for that. But I didn't start out trying to produce a mathematical model for the spread of pollution in the ocean. Okay. I started out with a very, very theoretical question of what happens when you have one fluid which is of higher buoyancy, so is less dense than another, and the whole system rotates. What happens? It's a difficult problem mathematically. So it's like super theoretical.
Right.
But then once I started, we built an experiment to recreate this, and I started thinking about what was going on, and then I read some stuff about pollution, about where does pollution come from, etc., etc., etc. And suddenly, the really like abstract theoretical stuff I was trying to figure out was like, well, this actually answers the question of where pollution is in the world.
Wow.
So like I didn't.
Yeah.
It feels like surely that was where I started.
Exactly. Because when I read your LinkedIn, I was like, I'm going to ask about fluid dynamics and how it links to ocean pollution. But if you told me you're in the first year of your PhD, this is what I'm studying, I'd look at you saying, cool. But...
Yeah. Because, I was like, this is an interesting problem. My supervisor agreed. He thought this was because it was hard. It was a hard problem. We don't fully understand it. And he was like, it'd be cool to try and figure this out. I was like, yeah, I agree. It would be cool. And then eventually, by like year 3, year 4, once I fully understood what was going on, then you begin to see the links. But wouldn't have necessarily known at the beginning. And like, the classic example is Einstein's theory of relativity, right? So at the time of Einstein's death, it was a theory, as in didn't have any practical use. But nobody would argue it was useless. But it wasn't being, it was incredible theory, how he described the universe. It didn't have a practical use until like 100 years after he first wrote it down.
Wow.
And like using GPS basically. So you have a relativity correction for the satellites orbiting the Earth that pinpoint where you are when you the little blue dot on your maps app. Yeah, exactly. So, without that, you just have a big 6-mile circle. You're in this circle without the relativity correction. So there are other ways that it's used, but it basically took 100 years to have a practical use.
Okay.
So like it's crazy because you just if you're now trying to fund Einstein's work, like it wouldn't be funded.
That's true. Yeah,
because he wasn't coming at it and being like, I'm gonna create a better app for your maps on your phone or whatever. It was just like I just want to understand how the universe works.
That's really interesting. So I think the moral of the story is be curious, study the curious problems, and something might come out of it, something might not. But if you don't try, you don't know. I
think so. I think, it's all we've ever done as humans is ask a question and try and answer it. And I feel like sometimes, especially in the modern world, you can be too focused on like, but why are you answering this? Right. Like, who cares about why you're answering? You're answering, the why is because it's an interesting question to ask.
That's really nice. And I think I wanted to ask, so you've now done your undergraduate degree and you're thinking about whether to do a PhD and whether to actually, did you ever consider going into industry? What I found is I'm in my penultimate year at university. And most people around me are now going into industry or looking at the investment banks or being a software engineer or trader. And I really don't know what I actually enjoy. So you kind of follow that path and I've applied for these finance internships. Did you ever have that dilemma and what made you choose a PhD path?
So when I arrived at university, I was just like, I'm just going to get a degree in maths and then I'll go and work in the city and earn lots of money and it'll be great.
Oh, so you did that?
I mean, I was 18. I didn't know what was going on in the world, right? So it's like, this sounds good, right? This is what people do. And then in my second year, it was one of my good friends who was doing maths with me. He just mentioned like he was going to this event about PhDs, and I kid you not, I was like, "What is a PhD?"
Really?
Had no clue. I didn't know that you could get paid basically to continue to study maths. I didn't have a clue because like no one else in my family had basically been to university.
Really? Okay.
So like, it was all new. So I was just like, oh, this sounds cool. And then, and then I went with him to the event and then found out more and more. And I was like, just couldn't believe that someone was actually going to pay me, obviously a pittance, but but I was going to actually get paid to keep studying maths. And I was like, well, obviously I'm going to do this now.
To keep asking questions, I'll get some money.
That became my goal. So I think I didn't realize it was something I could do. But then as soon as I did, I was like, well, I feel like I still have more to learn.
All right.
Like, I enjoy learning. I feel like there's still so much more maths that I want to learn about and ask about and discover. So it just sort of felt like the way to go. But I definitely did internships myself. So you're doing the right thing. I tried it out. I did various internships and just didn't like it.
Okay.
So, it was helpful for that purpose, right? Like
that's good.
Spent the summer with an insurance company and left it being like, Jesus Christ, I could not do this.
So I guess that pursuit of curiosity was greater than the pursuit of money, I guess, for you.
Yeah, no, definitely. I'm under no illusion. Like I'm very, very fortunate, I think, in that I can earn enough money doing something that I enjoy. That and it's great. But I also think that there's nothing better than enjoying your job.
Right.
Like I've got friends, who have, they work all kinds of hours and they earn 10 times more than I earn and whatever and get all these crazy bonuses and stuff. But like, they just don't seem happy.
Right.
Like,
yeah,
I don't know. Like I I just imagine, I've never woken up next to one of them, but I imagine they wake up on a Monday morning and they're just like, they just dread the fact that they have to go and, what their day is. Whereas I'm just like, I'm going to go do a talk and talk to like 300 kids about maths. I'm going to go record a podcast, just have just meet awesome people who are really excited about my subject. I'm going to go and teach my students who are like, really like energetic and want to learn and enthusiastic. It's just like such a pleasure.
When you say it like that, it seems like it's the obvious choice, but I think many people fall into that trap. And I think many people I've spoken to who are in that other situation kind of tell me that, but your job doesn't have to be your passion. You can earn as much money as you can and then use that money to fulfill your passions. Yeah. So I guess I'm not quite confusing, but
no, I think that is a very, very valid view. Absolutely. Okay. I think again, it's going to be a personal thing. But I think it's very easy, right? And this is like a well-known psychological effect, is that you sort of, I wouldn't say become addicted, but you get used to a certain way of living and a certain salary, and then you want to just keep striving for more and more and more. It's like very human to want to just keep, and like it's not to say I definitely want that, like I recently got a promotion at work and it's great, like I love it. I'm definitely, and now I'm like, okay, now I'm grade 8, how do I get grade 9? Like how do I become a proper professor? Like it's so like it's very human to feel that way. But I feel like often people have this idea, but then once you kind of get in the work kind of, bubble, adult, it is quite difficult to extract yourself.
Definitely.
I think it takes a really strong willpower personality, like, very, very driven and focused goals to not just kind of suddenly be trapped in that.
Yeah.
And that's not to say that people can't enjoy those jobs, right? Mm-hmm. There's also, I love all the stuff that I see on social media and read about, like about how to make your job more enjoyable, like trying to find fun in it and trying to
definitely,
do it through the relationships. Don't think about, who cares what the job is? Do you have colleagues you enjoy spending time with? That can make a huge difference. So, again, I sort of, I'm very aware that I am fortunate in that I found myself in the position I'm in and I enjoy what I do and stuff. But to me, it's always been, I think that's just always been my driver, and my goal was like, I just want to have fun. I just want to enjoy what I'm doing. And I don't think that would happen for me if I was working in a more corporate environment.
I love that. That's really interesting. So you touched on your PhD just a few minutes ago. So could you actually, in a simple level, explain what happens when river water enters the ocean, and how it spreads?
Yes. So you've got fresh water in the river.
Okay.
And then you have salt water in the ocean.
Yeah.
So the river water is lighter, as we would say, less buoyant. Mm-hmm. So as it leaves the river channel to enter the ocean, you would say that is an injection of buoyancy. Okay. It's an input of buoyancy into the environment, where the environment means the ocean. And then the whole thing's rotating because planet Earth is rotating.
Okay.
And that has an impact. So as the river water leaves the river, you can then ask the question, okay, well, where does the river water specifically go? Obviously, it gets mixed into the ocean.
Yeah.
But if you could dye it bright red,
okay,
where would that red dye, could you kind of track it? And obviously, you don't want to go and throw a load of red dye into the river. That's very bad for lots of reasons. There are some environmentally friendly dyes that you can use, but you need too much dye.
To see it, yeah.
Yes. But we do have some satellite images where the water is filled with mud after it's flooded and things, okay, and you can get good data from some of those images and things. But fundamentally, it's, as I say, it's a problem of you're inputting buoyancy, lighter fluid onto a heavier fluid, and it's rotating. And so the rotation is a big driver. In the northern hemisphere, it pushes the water to the right. In the southern hemisphere, it goes to the left. So this is due to the Coriolis effect, which kind of falls out from conservation of angular momentum and various other things. So that, first of all, is really important to know, like, which side of the river it's going to go. And then also it tends to form a, I describe it as a boundary current or a pollution-carrying current, which flows along the coast. Okay. And so a lot of my thesis then talks about, can we understand the properties of this current? So how deep is it? How far away from the coast does it extend? Is it a kilometer? Is it 10 kilometers? Is it 20? It's going to depend on the river. It's going to depend on the location in the world. There's, all of these factors and variables come in. And so ultimately, you're just trying to understand how big this current is that's hugging the coast. And then if you understand that again tells you where the pollution is. because 80% of pollution that's in the ocean comes from land, and it gets there through the river system.
Okay.
So that's kind of the idea.
Right. That's really interesting. I love how that came from that initial idea of just modeling the fluid around. I think you said
just what happens when you have two fluids with different densities and it's rotating.
Really incredible.
Just because basically anyone who has done any kind of fluids, fluid dynamics is a complicated subject. And as soon as you add rotation, the complexity it's on like 11 out of 10.
Yeah.
Like rotation just makes things so difficult.
I remember watching one of your videos actually about, it's completely unrelated, but there was a video where you talked about a rowing race, and if the rowers row at the equator, they can use 8%, they have 8% extra energy due to the lack of the rotation of the Earth. But if they do it in the UK, for example, they have to waste 8% of the energy. Could you just touch on that for anyone who hasn't? So this I found that really incredible.
It's crazy. So this is from I do a talk about mathematical modeling in sport. I talk about football, marathon running, and rowing. They're the three sports that I focus on. And the one on the rowing. So this was a study from back in like 2017 from some Australian scientists, and they just they just asked an interesting question and said, can you quantify the effect of the Earth's rotation on different sports?
Okay.
Because anytime you have anything moving, any projectile moving on the Earth's surface, it is impacted by the Earth's rotation.
Yeah.
Most of the time, it has like such a small impact. So they did it for like golf, and it's like a 300-yard drive is pushed like, I don't know, a millimeter to the side. Okay. So you just don't notice it because the wind is going to have a way bigger effect.
Right.
So you would say it's negligible.
Yeah.
Exactly. But they just said, well, let's just calculate it. Let's just suppose everything else, ignore everything else, and just look at the effect of the Earth's rotation. So it's not like practical.
Yeah.
But for the rowing race, it was really interesting because you're moving through water as opposed to air. So like the friction is higher, and so the impact is more. Right. So it's, if you've had any experience of like, swimming versus not, you can turn more sharply in a thicker fluid.
Yeah.
Whatever. So, so because of that increased friction, the impact is kind of amplified. And so they just calculated that in a 2,000 meter rowing race, you're going to be pushed like 80 meters to the side from the Earth's rotation because it doesn't go straight. Because again, similar to like what I was saying about the rivers. But then the calculation that they then did after that was to say, well, how much energy would you actually have to correct for? And they estimate, and again, it is an estimate, but they spoke to some rowers and tried to quantify it and said they think up to 8% of your energy is going to be used to kind of counteract being pushed to the side over that 2,000 meters. So like,
that's quite noticeable.
Yeah, professional athletes are like striving for that 0.1%, right, all the time. And it's like, just by doing the race somewhere else, if your goal is to break a rowing world record, like you just do it at the equator. Like I'd love to do this experiment, like to get like a world record Olympic caliber rowing team, and actually just be like, get them on board and be like, right, we're going to find somewhere near to the equator and we're going to try this because theoretically you should get, maybe even if 8% is an overestimate, they should get several percent increase, I think, in performance.
I love that. That's so incredible. It's a real well example where the mathematical equations are being used in real life to actually increase output, for example. I had a question. So if mathematics can be used to optimize so many different environments, do you think that a mathematician can enter basically any field and have an impact on maximizing success or optimizing that field? Or there's some fields which are quite hard to actually affect?
Good question. I think there's definitely something you can learn from applying maths to any of these fields, any of these subject areas. What exactly the impact would be, I don't know.
Okay.
But I think there is huge value. And you're seeing this recently in sports, I think, in the last decade.
Yeah. Right.
So again, I still follow football a lot and still occasionally try and play. A bit old these days, but the fact that now like every Premier League club employs a team of data analysts, they're just mathematicians.
It's true.
Right? They're literally just looking for patterns in the data to spot little things that they can use to help improve the team's performance. So I think that's a really good example of, you could take that concept and be like, let's get a team of mathematicians and let's parachute them in all these different environments. Some of them will have a way bigger impact than others.
Yeah.
absolutely. But I feel like almost all of them could help.
Definitely. That's really interesting, that sports example, because I love cricket, for example. And last summer I actually worked at my favorite cricket company as a data analyst.
Yeah.
And I was literally spotting different patterns that you don't even think of as a spectator. But when you start looking at the data, you're like, hang on a minute, if he moves his shoulder by X degrees a bit more, there'll be a better impact on the ball speed, which is really incredible as a computer scientist or mathematician.
Yeah, no, it's and when you find those moments actually where, for me at least, where the mathematical solution fits with what, let's say, the sports people do, that's my favorite thing. So for example, the sports talk I mentioned, so I talk about penalties, right? And you can turn, where do you aim your penalty kick to maximize your chance of scoring?
Okay.
Right, and you can look at this both by looking at data from successful penalties and also from like purely turn it into a geometry problem and be like, avoid, got to get it on target, but avoid the goalkeeper who's like modeled by a semicircle in the middle, various other things. And it turns out the answer is like about 1.8 meters off the ground and 0.65 meters inside the post. So obviously it's kind of towards the top corner, but not right in the top corner, because then you've got a very small margin of error, right? And then if you look at the best penalty takers, they literally put it there.
Really? Wow.
Yeah. Like any high pressure situation, not all of them, but like a good majority of the best penalty takers, especially when it's high pressure, like a cup final or whatever.
Okay.
They literally, like Harry Kane does all the time, smashes it right through the center of that point. And that's not because Harry Kane has done the maths.
Yeah.
He's learned through experience and practice.
For sure.
But I love the fact that the maths matches with what we've learned over 150 years of playing football.
I love that. That's really, really incredible. The last question I had just on this mathematics side was, so many people say, especially people who are not at a STEM university, they say maths is really boring, it's too difficult for me. But one example, which I remember seeing your video on, I think this is during COVID-19, where you walked through an example of the exponential growth, and I think you demonstrated how a single source can lead to 1,200 infections just under a month. So, and then you related that to, social distancing and why we should stay indoors. So that was an example which I personally saw as using maths as a force for good. Can you talk about any other ways to convince someone who might find maths boring or find maths obviously if they listen to this podcast, they've seen loads of examples, but how can you use maths as a force for good in society?
Oh, that's a good question. I would say, if you're trying to convince someone of the value of the subject, or maybe make them less scared of it, or less dismissive of maths, then it's like when we were talking about your example with the 4-year-old. It's take the maths to them, right? Because if you just give my maths, that doesn't work.
Yeah,
if you're talking, right, there's a reason I talk about penalty kicks in football, right? If I go to like a school and it's a room full of like 15-year-old boys. If I start talking about why Harry Kane's the best penalty taker, there's
a connection.
Yeah, that's the connection, and then they want to know why he's so good, because they're like, no, Messi's better or whoever, and I'm like, no, I'm going to show you the data. And then they want to do the maths,
right? Or
they don't mind that there's maths involved because they care, they're invested. It's I'm bringing it to their playing field, their world. So I think that, for example, with you mentioning the exponential growth idea. So if I just, started drawing graphs and things, like, no one cares. I remember having fun with that video because I put like 1,200 versions of myself on screen.
I was waiting for when you'd stop copying your face. I was like, when's too much?
Yeah, because again, I was just trying to think of like, how do I really drive this home to people? Because if you just see a number or you just see a graph, if that's not the way your brain is programmed and what you're used to seeing, you're not going to engage with it.
Okay.
So it was kind of like trying to
bring it to them.
Exactly.
I love that.
Exactly. So I think that's the way to hopefully share maths with people. And I also think that's how you can use it as a force for good, is, whatever, because it is a tool that it's incredibly versatile, right? Mathematical modeling can be used in almost any situation. I think my catalog of videos demonstrates, right? Like the range, like I'm talking about like which was the fastest dinosaur through to like modeling, ocean pollution or football, or right, like the versatility is there, and so I think it can therefore be a useful tool and can absolutely be used to help people make decisions, to understand things. But again, it's just you just need to bring it to their world and their playing field.
Okay, brilliant, perfect. So I want to now pivot slightly onto your tattoos, actually. So obviously, I mean, people might not know this, but how many tattoos do you have on your body? And can you talk about the meaning of why you get these tattoos permanently inked onto your body?
So last time I counted, it was over 130.
Wow.
Individual tattoos. I don't know the exact number. It turns out when your body is covered in tattoos, it's really hard to keep track of which ones you have and haven't counted. So what I really need to do is like get someone to help me and then like mark them with a Sharpie or something as we like, tick them off. But I know it's over 130. Last time I attempted to count.
All of them are maths or
no. So I think there's like 15 maths, I think.
Okay.
So obviously the majority of them are not mathematical.
Right.
But I think as with most people who get tattoos, or at least the way I think about like tattoos, is they are like a reflection of your personality, your interests, whether that's just because of a design you like, or it's like a thing that you like, or whatever it might be. So I have lots of like there's various like song lyrics and things. I've also got like video game characters, lots of like cartoon characters.
Wow.
And it's not that they're like super deep and meaningful. It's just like I really like South Park, so I got a Cartman tattoo. Like it's just one of those things. So they're kind of like a reflection of like my interests and personality and stuff. And like because math is such a big part of that, I think that's why I end up with the maths ones.
Okay.
So my right arm is basically mathematical.
Wow.
So like Can
you just walk me through that one, the ones with the lines and the pi?
The lines. Okay, so the pi is actually separate from the lines, but the lines are. Do you know the Basel problem at all? Pi squared over 6.
I've seen pi squared over 6 as a result, but I don't remember where it came from.
So it's called the Basel problem. So this is pi squared over 6. So the problem is, and it's actually I was talking about this today in the talk. So I was talking about it's the Riemann zeta function.
Okay.
This is complicated function, right? And it's $1 million prize about when it's 0. That's the Riemann hypothesis.
Is that the field on the Millennium Problems?
One of the Millennium Problems, exactly. And that was what I was talking about today. It was why I'm wearing my shirt covered in dollars, right? $1 million. That's the whole point.
Right.
So if you substitute in 2 to this function, what it then tells you is it outputs 1 divided by each whole number squared added together. So 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over... So it's 1 plus a quarter plus a 9th plus a 16th plus a 25th.
Yeah.
And you add them forever. And it turns out when you add them forever, it stops. You keep going, right? But it never gets past... it's definitely less than 2, for example.
Wow.
Right, which is like crazy because you're like, but I'm going to keep adding things forever, but you never get past 2.
Okay.
And it turns out you can actually show what the exact total is. And the exact total, it's about 1.6 something. Which it turns out is pi squared divided by 6.
Wow. So it reaches a finite value.
Yeah. So it's not just a finite value. They're like, why the hell is it pi?
Yeah, pi.
Right, like it's got nothing to do with circles. I mean, seemingly it has nothing to do with circles, right? There's a great video by Grant, 3 Blue 1 Brown, where he's kind of brings circles in and explains using lighthouses how you can maybe see why it's to do with pi and circles. But like you're just adding 1 over the square numbers and somehow you get pi squared over 6.
Wow. And that's the distance between each
value?
value?
So the first one is 1, that's a quarter, then it's a 9th, 16th, and then ... So the dashed line would be pi squared over 6. Because you never get there, because you would need to do this forever. Infinitely. So, we stopped after like 7 or 8 lines because my tattoo artist was like, I can't do them any closer together without overlapping. But that's like a visualization of the Basel
That's incredible.
problem.
And then have you got pi written here, or is that E?
This is E. So this is the first 120 digits of E.
Wow.
Around the top of my arm.
That's incredible. What would you say is, I mean, I'm sure it's hard because you've got so many. What's your favourite tattoo and what was the meaning behind it?
So that changes.
Yeah.
Recent one I've had done, I recently got really into... I've recently gotten really into fantasy books. Okay. So I played fantasy video games for a while. Like my favourite games are like Witcher 3, Skyrim, like that kind of vibe. Mm-hmm. And I recently got introduced to Robin Hobb as an author, and she is so freaking cool. Like the coolest woman alive. She like lives on a farm in Alaska with like 8 kids or something. It's just great. She just seems like such a badass. And she writes this incredible series of books called The Realm of the Elderlings. Huge recommendation for anyone who's into anything fantasy. Like if you are, you probably already read it all. So there's like 17, 18 books, and I just like read them all in like 6 months because I was just like addicted. And I got a tattoo of some of the dragons on my like leg. And I just love it because the detail is incredible. My artist did such a good job. And I really like it. Kind of goes past my knee. And so it kind of connects the upper part of my leg to the lower part because it felt like there was a disconnect between because I had some tattoos on the lower leg, some on the upper, but none that kind of, going over the knee is quite painful and difficult to design something. And the way we kind of threaded it through. So for various reasons, I think at the moment, that's like one I really like of like my more recent ones.
That's really meaningful. I love that. I feel like you can design your current passions onto your body so you can remember them when you grow older.
That's because that's the thing I get asked by people. They're like, but they're gonna look terrible when you're 60. And I'm like, first of all, I'm like, yes, I'm also gonna look terrible when I'm 60. It's fine. You're 60, you don't care anymore. Yeah. Like, something to be said for that.
Past the point in your life where
but I want to, and they're like, oh, you'll look at it and be like, oh, what a regret. But I won't. I think I'll look at it and I'll be like, I remember, the first time reading that book, and I remember, how amazing it was, like reading that story for the first time, or I remember, like, teaching my students this equation, or whatever it is.
That's true. All the memories come back.
That's what I feel like. It's almost like a scrapbook of my body in a way.
Could you talk me through the left arm quickly? Because I'm quite curious. There's so much going on there.
So there's all kinds on here. There's this song lyric. I've got 2 Pokeballs. Wow. I've got a sign from The Witcher. There's a YouTube logo. So I got that when I got my first 1 million views video. I got that as like a commemoration of making it, as it were, on YouTube. There's a QR code that works. So if you scan that, it goes to my website. So wow. I can change it to be a Rickroll if I want, because I own the domain, which is great. This is the main result of my PhD thesis. This is an image from one of my experiments. There's a gem, which is from Crash Bandicoot video game. The chain is from God of War, which is also a video game.
Wow.
So there's all kinds going on.
That's incredible. I love that. Okay, brilliant. So I guess the next topic I want to move on to was a little bit on the teaching side of mathematics. As a maths educator, I think we've spoken a lot about what your goal is as a mathematician to kind of bring maths to the student or to whoever you're speaking to. But is there anything in the way that mathematics is taught that you would like to change? So if you were having a meeting with the Prime Minister, for example, and you had to suggest some changes to the syllabus or the way it's taught right from the ground up, is anything you would recommend?
Okay, I'd say one thing would be to try and bring more storytelling into it.
Okay.
So, there's the sort of the classic question that I feel like a lot of students say, or the classic statement they might make about learning maths is like, when am I ever going to use this in my life, right? And I think that they have a point, right? You're not going to go outside and calculate the tangent of an angle. Like, you're not. I get that. But, so I think the way that you make that more interesting, because of course, the reason we're doing that is we're teaching them how to problem solve. We're teaching them actually how to think. Like we're, working out their brains. Mm-hmm. I remember something I saw on social media, which I think is I can't remember who it is, so I feel bad for saying this without giving the proper credit, but it was some page I saw. I think it was on Instagram, and it was from like a teacher. And they said that the way that they explain, like, they love it when a student says, why am I doing maths? Yeah. And they gave this example, and they said, it was like an American teacher, and they said it was literally like the high school quarterback. It was like, but why am I doing this? Like, I'm not gonna I'm not gonna go outside and work out the tangent of an angle or whatever, or differentiate a tree or, whatever ridiculous thing. And the teacher was like, so you're like the quarterback for the high school team? He's like, yeah. And they're like, and yet you go to the gym and you do bench press. Mm-hmm. He was like, yeah, love it. And was, like, I can bench whatever. And the teacher's like, you don't need to do bench press to play football. He's like, yeah, but I'm like working out my muscles. And the teacher's like, that's what we're doing. We're working out your brain. Your brain is a muscle. Wow. We're working it out. We're training it so you become a better thinker.
That's incredible.
And I just love that idea, right? Is like that, because again, that's the teacher's done such a good job of like bringing it to the level of the student and putting it in the context that's going to make sense to them.
Definitely.
Right? That's why we're doing it. So I think that emphasizing that is one way, but obviously that won't work with everybody. So I think what you can do is you just make it more fun by just bringing the stories. So it's like, take the example of trigonometry. Why did we first come up with trigonometry? It's basically, create a story. Be like, right, you're an explorer. Mm. You've just landed in South America for the first time back in the 1500s, right? And you're like, you can see a mountain in the distance. Is it worth climbing? I don't know. It'd be good if you could estimate the height of the mountain. Oh, okay. Right? And then you get out, you can do an angle, and you figure out the height of the mountain. But like immediately you're like, we wouldn't use it now because you just use your phone or whatever. But I feel like telling the story of like why it was used and how it was developed.
Yeah.
Or, you know, or maybe you just frame it in the context of like you're building a pyramid, you're in ancient Egypt. But like I think telling those stories, using that kind of creativity, like tapping into like the student's imagination or whatever.
Definitely.
I think it just brings it to life. And I think it can, even though they may still think I'm never going to use this, but at least it's like presented in a more exciting way.
And do you think Maths A-level should become compulsory for everyone?
Not Maths A-level.
Okay.
So I got asked about this a lot when this was talked about with the previous government.
Mm-hmm.
So if you're going to just make everyone do Maths A-level, it's like literally the worst idea ever. Because there's so many people where their brains don't work that way and they already struggle with maths. So just making them do more maths doesn't help.
Mm-hmm.
Right?
It'll make them hate it more.
Yeah. Like but what I think would be really good is to create some kind of qualification that has flexibility in it. So it's like, if you enjoy maths, you're going to do Maths A-level. If you don't enjoy maths or you're struggling with maths, here's what you do instead, right? Something like core maths. So I don't know if you know about core maths, but it's this awesome qualification that you can do that's like, I think it's a T-level or something equivalent. It's around like the A-level kind of category, right? And you would do it after GCSE. And it basically looks at like working out percentages, working out estimation problems. It's like finances. It's very like practical maths that people are going to need in their everyday lives. And so whilst that isn't perhaps going to be completely useful or interesting to students who are into maths, it's so good for people who just need to become more numerate.
Definitely.
And just be better at numeracy, just in terms of understanding like the world.
Yeah, I think that's really important. I especially think, even though I've done further maths step, that side of mathematics is still a bit more self-taught. So maybe if in the future, maybe not part of Maths A-level, but a separate side qualification could be introduced to all students, that'll be really incredible, because it's something every adult needs to know.
Yeah, absolutely.
Okay, and I just want to move on to university and teaching. So first of all, what's the process of becoming a lecturer at Oxford or Cambridge? Is there is it similar to the interview we have to take as students, or is it more about your research?
Well, it depends what the position is. So if it's a teaching position, then it should be dependent on your ability to teach. If it's a research position, it's going to be like, how good is your research, right? Which will be judged in the usual way of publications and, you know, colleagues' references and things. Mm-hmm. And, you know, and like your reputation within the field and all that kind of stuff. But like the original job I got was a lectureship at St. Hugh's College in Oxford. And I just applied, right? They were like, we need someone to come and teach. It was like a maternity cover thing for a few years. And they were like, we just want someone to come and teach. We need to teach geometry was one of the key courses. They wanted you to be able to teach first year geometry. So I applied, you know, and had lots of teaching experience from being a PhD student. So I think that helped a lot. Right. In terms of making, you know, that I had the experience when I applied, but also meant that I actually knew how to teach, having gone through that. Yeah. And in the interview, you know, they just asked me to prepare an answer to several questions. And then I just had to stand up on a whiteboard and just like teach it to them. And then they asked questions as though they were students. And, you know, and I just sort of, it's kind of fun, like, you know, having a room of like legit like maths professors sort of saying, but how is Pythagoras' theorem relevant here? And stuff like that. And it's like, I know you know the answer, but I'm going to pretend you're an 18-year-old who hasn't figured it out yet.
That's really interesting. Okay, and the last question to do at teaching was, do you prefer teaching or research? I know maybe in your role right now you combine the both, but if you had to choose one? So I actually don't do research anymore. Oh, okay. So my current job, I've been doing for the last sort of year and a half now. So I'm with the Department for Continuing Education. Okay. Rather than maths. And that's because I've kind of pivoted. So because of all of the engagement-based things that I'm doing and outreach work and, you know, YouTube and TV now and various other things, that's now like built into my role. Yeah. So my new title is I'm the Public Engagement Lead for the department, which basically just means they give me the support and opportunity to just do all of these things about raising the profile of the subject, raising the profile of the university, the department, etc., etc. So I spend most of my time, non-teaching time, doing that now. Okay. So yeah, it sort of felt like I'd reached a point where I was doing three things. So I thought of it as like, I'm wearing three hats. I'm teaching, I'm doing research, and I'm doing all of this kind of public engagement stuff. Yeah. And it had just reached a point where I was struggling to do all three. Yeah. And so for me,
I decided that research was my least favourite of the three.
Mm-hmm.
So your original question of which one do I prefer, definitely teaching.
Okay.
Yeah.
Okay, perfect. Now I want to move on to a topic which I personally look forward to for a long time, is countdown. I'm sure you've had a lot of questions about this recently, especially because it's been on the news and you've been on TV past few weeks. So the first question I just had was, could you walk me through how this countdown idea came to you? What was the interview process like? Why did you apply for this role, or did someone approach you?
So I did have to apply, but I was approached, and it was one of those, like, so being, I guess, active online and publicly visible as a mathematician means I get lots of very exciting emails, right? I got one this morning inviting me to go to Spain for a week and teach in a palace, which I haven't fully read, but I was just like, this is ridiculous.
I saw you went to UAE recently as well.
Yeah, and it's awesome. I love it. I'll go talk to anyone who'll listen to me, to be honest. I get to talk about maths. And it was just an email saying, there was from a production company saying, there's an upcoming television opportunity. Might you be interested? It requires someone with math skills. And I've had a few of these before. And usually, I'm like, yeah, sure. Like, I'm certainly interested. It sounds like fun, right? Again, any opportunity to bring maths to more people. But they didn't mention what it was. And then we had like a Zoom call, which is like classic in this situation, where they record it. And then, they just ask you about you and different things and your experience and whatever. And it's then just gets recorded and like shown to like the producers of the show and different things. And that's when they mentioned that it was Countdown, and I was just like, oh wow, okay.
And I'm guessing you've seen the show since you were
I used to come home from school and Countdown was on TV, right? It's like it's just like, it's, if you grew up in Britain, right, you watched Countdown, like it's just part of like the furniture of the UK. And so then it was mentioned, and then the chat went well, and then I guess they liked me, because then I got invited for like the proper audition.
Okay.
So I think there was a few of us. We were all at different time slots, so we didn't I didn't get to meet anybody else.
Right.
But I know like I wasn't the only one. I can say that with certainty. And again, I don't know exactly how many of us came along, but like they'd set up like a mock studio, and then they were recording it, obviously. And they were just giving us number puzzles, so we had to do
had to do them.
Of course, because
they can't take your word for it.
That's the thing, that your job really is to solve the number puzzle.
Sure.
So they got progressively more and more difficult. I managed to solve most of them, actually.
Wow.
Which
did you have to kind of, obviously you've watched the show, but there's a difference between watching.
No,
and
I prepped.
Okay,
prepped. Once I knew what was coming, I there's lots of like standard techniques and stuff which I've been talking about.
Split multiplication.
Exactly, right. You've been watching. I've been talking about these things. So like with anything, I practiced and learned those particular techniques. Okay. It would have been quicker and easier for me because my brain, I'm used to learning maths, right? Mm-hmm. But they were new techniques that I just had to get good at. I did put in the hours and practice and stuff. Played lots of, got an app on my phone, was playing all the time and nice. Different things, and got better and better. Obviously it worked out. The audition went well, and then they phoned me a week later just to say, we'd like to offer you the role. So
that's incredible. Well, congratulations, and I've loved watching it.
It's been good fun.
Okay, so before we move on to more questions, this has actually been the part I've looked forward to the most, is that I've developed a small program which just generates the numbers. So I'll just, give me a second, I'm going to pause the podcast.
You're going to make me do countdown puzzles.
Yes, if that's okay. But in my defense, I'm representing the average public in terms of, I've watched Countdown, but I've never really done it myself. So I just want to see how quickly you could solve it compared to me, given that I know no techniques, not too many techniques.
I love that you coded it when they exist on the internet. This is like
it exists.
Such a computer scientist. No, of course they exist.
No, I was originally just gonna use a random number generators online, but I thought, why not build a web app? So everyone should be able to see this. We'll just try maybe 1 or 2 rounds.
Let's give it a go.
And just see how it goes. Just a disclaimer, I don't think I'm going to get them anywhere close, but I'll give it a go. Okay, so it says, how many large numbers would you like?
So the classic is 1. Most contestants will pick 1. So let's start with
1. So I'm going to press start, and then it will automatically.
Will we get the music and everything?
We won't get the music, so I'll add the music in when I when I edit it. I'll add the music in. But
all right.
Okay.
Oh God. Okay. 50, 10, 1, 4, 4, 5.
Oh, that's the easy one to start with.
Yeah, I got that.
Okay.
Cool.
Oh no, I haven't got that. Oh no, this is stressful. This is embarrassing. I've got.
And that is time.
Oh.
What did you get? You got to declare your score.
Do I have to declare it?
Yeah,
okay,
you got
I
to declare. What did you get?
50 times 10 is 500.
Oh no, you don't need to tell. What did you get the target? That's
Okay,
the
I need
question.
to still calculate what I got. 500 plus 20 times. Oh no, I got 600.
So you are very okay. You've got to be within 10 to get points. So.
Okay. So please, can you enlighten me how to get this one? I thought this was an easy one actually.
I actually I don't mean this in a nasty way, but observing you do this was actually amazing because I feel like you immediately experienced how much different it is compared to like when you're sat at home watching on TV.
Definitely.
It's the easiest thing in the world.
I felt the pressure even though there's no one watching.
And there's no music. Imagine
Yeah.
the music blaring and everything. It is actually, and this is something I think is really important because you see this with the contestants
Definitely.
as well. That again, for them, it's probably even worse because they're in the studio
And they
the
know
cameras.
it's going to be on TV as well.
So like you do, so I think it is, you can't underestimate how much harder it is in the studio with the pressure, the lights, the cameras. Like it makes a huge difference.
Just on that point, I had a, do you know Tim Campbell from The Apprentice? So there's a BBC show, The Apprentice. So I had him come to Imperial and we did a fireside talk. And I asked him a question saying, when you're at home watching the telly, you're kind of just shouting saying, oh, wow, that's such a silly mistake to make. And you'll think, I would never do that if I was doing that task. But he was saying, you got to give them a little benefit of the doubt because it's so much pressure knowing that everyone's watching you, you're being filmed. So I think it's similar to what you said.
Yeah. So this one, this is classic split multiplication, right? Because I can see you try to sort of do that. So
that's why I drew the brackets as well.
So you jumped in with 50 times 10. So what you want to do is if you add the 5 first, 50 plus 5, and then multiply by 10.
You get the 5.
You got 550, and then you've got a 4 left.
Okay. I was going for that in my head. I didn't quite get
obviously, putting it into practice,
Okay.
yeah, it's tricky.
Okay, we'll do we'll do 1 or 2 more if that's okay.
Sure.
Okay.
It's your turn to pick, right? I pick one large, so you can pick.
I kind of like the ones in your video when there were 6 small. I thought they were quite interesting.
The mathematician ones. How well do you know your prime factors?
Okay, so I'll just do 0 and stop.
You've got a lot of 10s. Okay. Ooh, this is tricky.
This is very tricky.
This is hard. We're up. Okay, I've definitely got 850, so I can at least declare a score. But I feel
what
like
did I get? I got 10 times 3. Oh no, I didn't. I got 120.
God, so how
I was thinking more than
that's a tough one.
I was trying to draw the prime factor decomposition tree.
Oh, okay, so you went that way so I didn't. I went big, so I went 9, 10, 10. Gives me 900.
Okay. And then subtracted 5 times 10.
Well, that would give you the 8. So that was like my backup in my head,
Okay.
right? But obviously I'm supposed to get the actual answer because then I want to use split multiplication. So I want to take away, like, if I take away
just
a 5...
for someone who doesn't know what split multiplication is, could you quickly...
Yeah, so the idea is I've done 9 times 10 times 10.
Mm-hmm.
And then, for example, if I didn't have another 10, I do, but if I didn't, then what I can do is I want to take away that 50. So if I take away the 5 before I multiply by the final 10,
right,
it's the same as taking away 50 from the final answer.
Yeah.
Right? So that's one way that you could do it without using that other 10. But then the problem is you're trying to take away 52.
Mm-hmm.
And
but
so
there's no 2.
So there's no 2. You can get a 3 from the 7 and the 10.
Yeah.
You could get a 2 from the 10 and the 5.
10 divided by 5.
But then you've lost the numbers you could use to take away.
Wait, could you not do the 9 times 10 times 10, then minus 10 divided by 5 times... So in the split multiplication bracket, what was that? No,
because if you take away, because you could take away. Oh, I've got it. Oh, I got it. Yeah. A little bit late, but okay. So you want to do 10 times 10, right? And that's going to give you 100, and then I'm going to multiply by 9. But before I do that, I'm going to minus 5, and then multiply by 9.
Oh my gosh.
I think. Oh wait, I have got it. Good. Okay. So you don't need to know. So you just know it's 900 minus 45. So that's 855.
I was trying to do 95 times 9.
Yeah. So you never do that, right? You know it's 900 minus the 45. So that's 855. And then you've got the 3 from the 10 minus 7 is what's left. So 10 minus 7 gives you 3, and then you take that away.
Perfect. Wait, sorry, but 855 minus 3 is 852.
Oh, quite. Sorry, yeah, I'm being an idiot. I thought I was trying to get...
Fine.
I was trying to get 852. So we just take away 7 from 855.
Oh, perfect. And you've got...
Even easier, yeah. You don't even need the last 10.
Wow, okay.
That's because I was out of practice.
Yeah.
I think I'd have got that one on the show.
I gave it to you on the spot. Okay, we'll do one last one for luck. Let's see if I can get any closer.
Try 4 large, because that's the other tricky one.
Oh, the tricky one, okay.
Yeah. So 4 large, it's both tricky, it's both easy and hard. So it's hard because you have to deal with big numbers.
Yeah.
But in theory, it's the one you can practice because you know what 4 of your numbers are.
Yeah.
Right. So
before this podcast, I was trying to memorize the 75 times table.
Yeah.
Because I know the other 3 obviously, but didn't know 75.
Yeah, exactly. That's also a good sort of beginner tip. Like just learn your 75 times table. You need to know 75 times 7 is 525 without even thinking.
Okay. Yeah, I did not know that one. Okay, let's have a go.
Ooh, you've got a bug in your program.
Got a bug?
Because your target number is 57.
Oh, and
it has to be 3 digits. So the
I
rule
just did a
is
random
it has
number.
To be, yeah.
I did. Okay, let me quickly just fix that. I did a random number from 0 to 9.
I apologize. It's not a bug in your program. You have slightly
misunderstood the rules.
So it's from 100 through to 999. Yes.
Okay, there we go.
Yeah, because they don't do 2-digit targets.
Found the bug.
Oh god, here we go. Okay. So we got 1 and 5. Okay.
Time.
Yeah, no, I'm miles away. I can get you. What can I get? Hang on, I can get 9.
I got 900.
I can get 900.
I could get 950. Okay.
Yeah, I've got 9.
Well, I did it after the time.
5-3.
Wow,
which is still pretty bad.
I got the.
I wonder if that one's solvable. You know.
When you do countdown on a TV show, you don't know if they're solvable, right? You can.
So the only thing I was told is, because obviously we have an earpiece from the producers.
Yeah.
The only thing you get told is if it's impossible, they tell me it's impossible.
Just you or the
just me? No, because the contestants still have to. They can still score points.
Okay.
Exactly. So you don't tell them, but they would just tell me so that I'm not like stressing myself out, right? Because obviously, if I'm like frantically trying to get something that's impossible, so that is the only thing.
And how likely, like when you pick a number from 100 to 999, how likely is it that it's impossible?
So I think it's like
not as a probability,
at least 1% of them.
Oh, really?
1%. So 1% of all games, but I think it's as high as 10% for the 4 large and for the 6 small.
Okay. Wow.
So it is
like kind of.
So if you pick the extreme games, right, where you have the 4 large and the 0 large, in those extreme games, it is reasonably likely. Right, so that if you have enough of those, that you'll get one that's impossible. So I had a couple. I think there were 2 or 3 during my time on the show.
Okay.
So across like the 60 rounds that I did, I think there were 3 that were impossible. Maybe.
Okay. Wait, this might be a trivial question, but how do you actually know if it's impossible?
So they use a countdown solver.
Oh, okay. There is a
solver.
Which
so
brute forces
I think we should
or?
check this one. I think we should.
Does it brute force that or?
I honestly don't know how they work. You probably know better than me, being the computer scientist.
No.
So, which one's a good one? I think it's just this one. Yeah, this one works. Right. So what do we have? We have. It's probably doable, actually, now I think about it. But anyway, let's see. Just to be sure.
I use split multiplication.
Got it. Okay, it is doable.
It's doable.
Okay, so it's doable, but it's horrible.
Okay.
Because, right, so the solution that we're seeing, we cheated and used a countdown solver. I have no issues not getting this one. It's 1,000 times 50 to give you 5,000.
I would never have gone that high.
Then you take away 75 to get 4,925 and divide that by 5 to get 985. And then
oh my gosh,
you're 24 away and you've got 25 and a 1. Like, that one, I think, it's doable if you're used to the four large.
Okay.
Right, because one of the things you would use in the four large is the idea of like going up into the thousands, knowing you still have another large left to come back down. Okay.
So
that's something that you do, right? You would know, for example, that 4925 divided by 5 is 985. You would just have this kind of knowledge in your head with that practice.
Right.
But yeah, no, I think that would be a very, very tough one to get in. If anyone got that in 30 seconds, I'm seriously impressed.
Okay. Well, I think on that note, we'll leave the countdown solver there. Sorry, the countdown game, but thank you for playing that with me.
No problem. It's good fun.
I've got a lot to practice.
Me too. I would practice.
So when I was young, I used to love watching Numberphile. You've done many of them. Which ones would you pick as your favourite?
I mean, it's hard to look past my first few.
Okay.
Right. So when I met Brady at a YouTube conference and convinced him that I would do a good job.
Uh-huh.
I was talking to him about maths and saying I do research, and I was like, you haven't covered Navier-Stokes yet. And I was like, I can explain it for you. You haven't done it yet. And
that was literally the next question.
Right. Actually. Yeah. So I think it's hard to look past that because we did Navier-Stokes, and then I just remember like obviously not knowing whether I'd done a good or bad job or whatever, but obviously having prepared loads and things. And then he just kind of looked at me and was like, you got any more? And I was like, okay, he likes it. Like,
How does it actually work? So is it a one-man band?
Yeah, it's just Brady. Brady turns up with he has like a proper camera.
Really?
Like he used to be a cameraman for TV.
Okay.
So that's why.
Is he also a mathematician or is he just...
No.
Oh,
no. His background is like journalism and media.
Wow.
But obviously he's very into like learning and curiosity, and yeah, very much so. So no, he just, so we filmed the first one, and then he was like, you got any more? I was like, I've got plenty more. And then we obviously filmed another 2. And then, so now he pops up in Oxford about once a year, and we film like 4 or 5.
That's amazing.
In a day. I'm actually filming tomorrow.
Oh, for Numberphile? Oh, wow. Keep a lookout in a few weeks.
Yeah. That'll be, over the next sort of 6 months, it'll probably slow release. I don't know how many we're going to film tomorrow. I've got 4 or 5 ideas that I'm going to finalise this evening.
Wow.
Ahead of film tomorrow.
And could you just talk me through that Navier-Stokes equation? Because I don't know too much about it, but I read that it's an equation that could solve everything once. Is that the one?
I wouldn't say it could solve everything.
Okay.
It's a set of equations that describe the behavior, the motion, the properties of anything that's a fluid.
Right.
So obviously I was studying it in the context of the ocean and this interaction between river water and ocean water. Navier-Stokes equations are used for climate models, because they explain how gases are fluids, right? We mean liquids and gases, basically. So the way that the atmosphere is responding to changing temperatures, like even weather patterns, long-term variation, which we call climate. So that's all Navier-Stokes. There's really interesting work around like blood flow through the body. Because again, blood is a liquid, right? It's a fluid. It has obviously solid particles in it, which makes it a more complicated problem. But there's really interesting stuff about designing drugs, like pharmaceutical drugs, that can be absorbed faster by looking at the fluid flow of blood.
Oh, wow.
It's like, so there's so many
applications of...
Yeah, and obviously anything aerodynamics, building faster Formula 1 cars if you're into sport, or building rockets. It's all aerodynamics and things. So it's very, very versatile set of equations. But obviously I was looking at them particularly for the fluid dynamics, the context of the ocean. Yeah.
Okay, brilliant. Okay, so we'll finish off with 2 last main questions. So one was on artificial intelligence. What do you think is the future of artificial intelligence in the context of obviously data science and mathematics can help discover loads of patterns. And as a mathematician, you deal with patterns every day. So what do you think is the future of AI in society?
Well, I think you've kind of nailed it in the question.
Okay.
So for me, it's like I would use it to do the things that it's good at. Okay. So what it's good at is pattern spotting, right? Because it can deal with way more data than a human can deal with. Mm-hmm. So I think that's really important. But then the understanding, let's say, the reason for the pattern, to me, that requires the human.
Right. Okay.
Right. So AI is going to pick out the pattern.
Okay, but it'll never replace.
And then you need the human, from my perspective at least. You then need the human to come in and be like, well, why is the pattern here?
Right. Okay.
So my experience with, and I've made a few videos about this, of like using ChatGPT to try and solve math problems, is it's terrible.
Okay. Yeah.
Because it can't think logically.
I know it's not out the hard way doing my coursework.
I people get very defensive of it in the comments. I know it's not designed to understand logical statements. I get that. You know, it's a language model, etc. But it did surprise me how bad it was actually. You know, it would say statements like, clearly 1 is greater than 2. And then it would go on to just...
And it's so confident about that one premise.
That's why it can be dangerous, actually. I think there would be a lot... I understand why it's written this way, but I think there would be a lot to be said for if it said, assuming 1 is greater than 2. And then it's kind of emphasizing that it's not
based
sure.
On that assumption.
Yeah, okay. Right? Because, I don't know. So I think there are different... But again, I do understand why it's presented as it is, because otherwise you wouldn't believe anything. So it's sort of gone... But for me, it's gone a little bit too far in that overly confident direction, right? That it's but yeah, no, I think it's a really, really helpful tool, absolutely, and we should be using it for things that humans aren't good at. But I think you should absolutely be using humans for things that humans are good at.
Okay, and what's next for you? So obviously you love teaching, you love doing these public engagement activities, but what's the next thing for you?
More of this, to be honest. I mean, it's kind of, I don't think I've ever really had like specific goals beyond just I'm enjoying what I'm doing. It's amazing to share maths with people, to share my enjoyment of maths with people, to see how much they enjoy maths. It's crazy to think that anybody watches anything I make. It's wild when you actually think about the numbers.
I think
insane.
I speak on behalf of everyone that you I think we touched on it earlier, but your passion for maths is quite infectious. It makes you really enjoy it and think about maths in ways that you just would never. I mean, even just today in this 1 hour podcast, ocean pollution to sports to countdown, like anything at all. I think the way you bring maths and make that accessible to everyone. So I think we're really grateful for that. But thank you for doing that.
No, that's really lovely. I never know how to respond when people tell me these lovely things, or like when people, as you said, were stopping me outside for like autographs and photos. It's like it amazes me. I'm just some dude who likes maths way too much. Like, but I love the fact that this community exists. Like, it's incredible to see. So yeah, I think, you know, I don't even know how I would describe what's next. It's just, I'm enjoying what I'm doing.
Just living in the present, I guess.
Yeah. It's just like, I just want to keep doing this, right? And whatever that means. So if that's thinking bigger and, you know, thinking of bigger projects, you know, so like, for example, recently being on Countdown and being on TV in front of millions of people. Awesome, right? I'd love to do more of that. You know, like think bigger, better. Like, can I make more ridiculous YouTube videos? Like, you know, can I don't know. Yeah, there's just so many things. It's just sort of thinking of bigger, more interesting, like pushing the boundaries of ways of reaching new people with maths and new ways to bring maths to life.
I love that. And lastly, I had a question about if you put yourself in the position of a second year or third year maths undergrad or computer science or any quantitative subject, what advice would you give to them? So obviously there's many upcoming fields in mathematics and research. What advice would you give to someone studying right now?
Okay. If you're thinking really practically, because of the way you framed the question, if you're thinking really practically, then the future is definitely to do with data, to do with AI, to do with machine learning, etc. So like if you're thinking really practically, do learn about that. Learn how that works, because right now, and I've seen computer scientists like, you know, the equivalent of a Nobel Prize winning computer scientist giving a lecture and saying, we need mathematicians to help us understand these magic black boxes we keep building. Yeah. They're like, we build them and they work and we don't know why.
Why? Yeah.
It's like, we use the method of steepest descent because somebody somewhere figured out it was good. We don't know why it works. Like, they need mathematicians to help us understand how AI
Because we'll need to
functions.
innovate in the future, so we need to kind of try and understand the why.
So I think that is that you can really position yourself, right? If you have those skills, I think that's going to be, thinking very practically. But I would say my main bit of advice would be to just have fun with it.
Okay.
Like do, if you're really into, I don't know, if you're really into algebraic topology, go and study algebraic topology. Like, because you enjoy it.
Don't think about the outcome. Just study it because
you will become a better mathematician. You will become a better thinker, a better person by doing that, and you'll have fun along the way. Which to me, like the whole point of being a human is to have fun. That's my take on life.
I love that.
We're going deep on messages. My take on life is find what you enjoy, find what is fun to you, and just do it.
I love that. On this podcast, we love deep messages. Brilliant. Okay, and I just want to end quickly on a few quick fire questions, if that's okay.
Sure.
So first one is, do you have a favourite maths joke by any chance?
Yes. So it's a maths chat up line. So you can say to somebody, let me just think about how you say this. You say to somebody, you are the square root of 1 plus tan squared of c.
Okay, tan squared of c. What's c?
So c is just a constant.
Oh, c is just a constant.
So it's like normally it would be tan squared of theta, right? But tan squared of c.
Okay.
There we go. So
that's really nice.
It will only work on people who are literally doing a degree of maths.
Yeah.
But it is an excellent line.
Okay, second one. If you could write a book today, what would the title be?
I'm writing a book.
Oh, wow.
The working title is Fantasy Mathematics.
Fantasy Mathematics. And I guess that relates to your passion of fantasy.
Mm-hmm. Yeah, it's going to be like looking at the maths of Pokemon, the maths of Harry Potter, the maths of Lord of the Rings, just all of those big fantasy fictional worlds. I'm just going to be like asking ridiculous maths questions about them.
I love that. Look forward to reading it. Third question. What's your favourite place to travel to?
Ooh, that one's tricky because I like to travel a lot and visit as many sort of different places. I like
you had a maths on tour or something where you just travelled around?
That was last summer. Yeah.
Okay.
I just got invited to do talks everywhere. So actually, I think it's not a particularly unique answer, but it's having only recently been to New Zealand for the first time last year. It's hard to look past New Zealand.
Okay.
It's just such an incredible country. Like, just everything is beautiful. And also, as a huge Lord of the Rings nerd, right, I got to go to Hobbiton and go inside the Hobbit houses and run around the plains of Rohan where they filmed that, and it was so cool. Yeah,
that sounds really incredible. I've never been to Australia or New Zealand, so hopefully
I hadn't until last year.
Okay.
It's a long old flight, but it's worth it.
Okay, and what's the most beautiful mathematical equation in your eyes?
I mean, it is just Euler's identity, isn't it? Like,
is that the e to the I pi?
Yeah,
Okay.
But what I would say is that, so I have it tattooed. But the one that I like is e to the I pi plus 1 equals 0. Because some people prefer e to the I pi as minus 1.
Yeah.
But I like the fact that you get the 5 constants, right? So you've got 0, 1, I pi e. I like the fact that there's the 5. Because minus 1, who cares about minus 1? I like the 0 and the 1 in there.
I care about minus 1.
Okay.
Do you get the joke?
I do.
Sorry.
I do.
Okay, and lastly, what's the best advice someone has given you?
Oh, okay, yeah. I would say the best advice I've been given is when you're creating content, so social media, YouTube, etc., if everyone likes it, it's rubbish.
Wow.
Because if you try and make everyone like it, then you're just making it vanilla.
That's really interesting. I think you can kind of extend that to life.
Yeah.
If you're trying to please everyone,
you end up just being you just become beige walls everywhere.
right?
Right. So I like that. I think that's something that there's nothing you can do that so it's important to let me think about this. You're always going to get negativity on social media, unfortunately. Like,
sure.
Humans be humans, right? The internet is the internet. But I think I found it really helpful to think about it in that context. Because as soon as you know that if the fact that people don't like what I'm doing, like, that's actually good.
Yeah.
Because it means I'm doing something unique. It means I'm doing something different. And so I think that
being creative, I guess, thinking outside the box.
Yeah. So I think, I don't know, it's just something I found really helpful was just, and I actually can't even remember who told me this, which is really bad. I'm very bad today at remembering, giving credit to people who've told me cool things or whatever. But yeah, sort of if everyone likes what you're doing, then you're doing a bad job.
Brilliant. Well, on that note, I just want to say a huge thank you from me, because you've inspired me ever since I've been a child to study computer science or mathematics, and for your time today, because I think hopefully you've inspired someone listening today, and I really appreciate your time.
My pleasure. It's been great fun. I hope there was something vaguely interesting and useful and enlightening in all of that.
Perfect. Thank you so much.